Hello, in this video I would like to explain how to do implicit differentiation problems. And in first case it's a question from your textbook, and we will do just implicit differentiation or finding y prime, derivative of y. So when you do implicit differentiation, you have to remember that x is independent variable, y is a function of x. So we have to apply the chain rule every time we differentiate y. So for instance here, we have to differentiate left and right side. And you can use brackets or you can use parentheses, it doesn't matter. And here you differentiate right side. In this case it's constant 0. So the derivative constant is 0. So but what will be the derivative of d dx? This is d dx of x squared, 2x. What will be the derivative of y squared? Here we're applying the chain rule. It will be 2y multiplied by y prime. What is the difference between these two, x squared and y squared, when you differentiate? X is independent variable, so it's not a function. Y is a function, so we need to apply the chain rule, and then derivative of x is 1, so you multiply -4 by 1, or just -4, plus again 6 derivative of y prime. Derivative of 9 is a constant 0, and we have 0 on the right hand side as derivative of 0. Now we need to collect all terms with y prime and everything without y prime, which is here and here. We need to move to the right hand side. So I'm going to collect these two, and at the same time I will factor out y prime. If I factor out y prime, in parentheses I will have 2y left from here, and here I will have 6. On this side I will have positive 4 subtract 2x. So we subtracted 2x to move to this side, and we added 4. Now we need to divide by 2y plus 6 to get y prime by itself. So we'll do this to both left and right side, and we have so you cancel on this side and you have y prime. Now you can see that numerator and denominator of this rational expression has common factor of 2. So we're going to factor 2 in numerator and have 2 minus x in parentheses. If you open back, 2 times 2, 4, 2 times negative x, negative 2x. And the same we do here, 2y plus 3. As you can see, we can reduce y plus 3, and we can reduce this expression, and final answer y prime equals to 2 minus x, or minus x plus 2, either way, over y plus 3. So that's the answer. And the second question is also from your textbook. In this case, the question was about finding the slope of a tangent line at the point 7, 0. The slope of a tangent line, as you know, at the point is the value of the derivative at the point. So we need to differentiate this expression first to find the derivative y prime. So let's differentiate left and right side, d dx of y squared and d dx of this right hand side, the whole thing. So I'm going to continue. What is the derivative of y squared? Y is a function. 2y times y prime. We have to multiply by y prime because y is not a single variable like we have x here, but it is function of x. So on this side, I use their quotient rule. So I square their denominator, like so, and I find derivative of x squared minus 49. It will be just 2x, because 49 is a constant, multiplied by their denominator, x squared plus 49. And then on this side, I will have to subtract. Now we keep numerator, x squared minus 49 multiplied by the derivative of denominator, which happened to be coincidentally 2x as well. Instead of opening parentheses and combining like terms, which I could do here, could open parentheses, distribute 2x and distribute 2x. On this side, I decided to factor, since I have 2x, I decided to factor out 2x and have something like this. So I take 2x outside, and then in parentheses, again, you don't have to do this. You can distribute and combine like terms, but I found that this will be easier for me, and I show you something different here. Easier for me to combine like terms. And the denominator remains the same, x squared plus 49 squared. Now, as you can see, when we open parentheses, we get rid of x squared, and negative 49 becomes positive 49. So what happens next? In numerator, we will have 2x times 49 twice, which is 98. 49 plus 49, 98. 2x times 98 over x squared plus 49 squared. Now, you can multiply 2 and 98 and get 196, or you can see that to find the y prime, you have to divide both left and right side by 2y. And dividing by 2y, it means like you multiply by 1 over 2y. So that will be cancellation of 2. And your y prime left on the left hand side will be equal to, after we cancel this 2 and this 2, we have x times 98. 98x in numerator, and in denominator you have y times x squared plus 49 squared. Remember, we had square here. Let me write that square better. So squared, and we have it here. So that's our derivative. Our derivative at the same time at the point 70, it will be the slope of the tangent line. So what do we need to do next to answer this question? We need to evaluate the derivative at the point 70. X equals 7, y equals 0. So when you plug in at the point, you get 98 times 7. Now y equals 0, so division by 0 is undefined, and here you have 7 squared plus 49 squared. So division by 0 is undefined. We know that this product will be 0 at the bottom, and we divide by 0. So this slope of the tangent line at the point 7, 0 is undefined. What does it tell you? What kind of tangent will be at that point? Undefined slopes we have for vertical lines, so the tangent line is a vertical line at this point, 70. So we answered both questions, and I hope this video helps many of you to understand implicit differentiation better. And if you have any questions, feel free to send them to me. Thank you for your time.